Thank you. Yeah, I started recording. Okay. Can you please tell me, Srini and Mani, about uh, the problems, whether you are able to solve it or not, the yesterday one?
No, actually, I did not even try them. Maybe I'll try them all of them tomorrow. Today I have like couple of interviews in the line,
Okay.
right? So I'm preparing for them.
Okay. How about you, Srini?
I did those. Yeah, I did those.
Okay. Can I see the programs?
Yes, yes, sure. Did you make me presenter? I
I'm
did
sorry.
not get that option.
You are the presenter now.
Yeah. Uh, these are the five classes which I wrote.
Okay.
This is the array sort.
Okay.
I just did that. I provided five numbers and the sorting happened. I did not. I hard coded five occurrences for the array and
Okay. You hard coded to size to 5. Okay.
yeah.
What you can do is when you say array dot arr dot length, it gives the array size. You don't have to put that value 5, etc.
Okay, okay. So dynamically user can provide the size of the array.
Yes, you can provide the size of the array. So in line number 7, if you say instead of
Okay.
telling int of 5, you give any user read variable like n, then it will be
Okay.
creating that many number of elements.
Okay. I will change that. Mhm.
Yeah. Okay. How about the other ones?
This is the even number between two numbers. So this program accepts two numbers and displays all the even numbers in between them.
Okay. See, there is a slightly better way of doing this program, isn't it? See, if number one, number three is equal to number one, what we are doing, what is number three? Uh,
Number three is just an intermediate number. I'm starting with the let's suppose number one is the first one and number two is the second number. I'm
okay,
starting from number one plus one and
okay,
up to number two, less than
okay,
number two. I mean, I'm printing in between numbers, not the. I don't want to change the numbers which I accepted, so I created a intermediate number.
okay. So it's just like a counter that moves from one place to another.
Yes, yes, correct, correct.
In number three equals to number one. Okay. See, there is a slight improvement that you can actually do. That is, you don't really have to check for every number whether it's even or odd. Okay, what you can do is you can check whether the number three is odd or not in the beginning before the loop itself. If it
Okay,
is odd, you can simply increment that number three by one. Okay, and
got
then
it.
in the loop you don't have to verify at all. Instead of doing number three plus plus, you can do number three plus equals to two. That
Yes,
way,
correct.
so you don't have to verify for every iteration, and you don't have to visit every number.
Right.
Okay, so
Got that point. Yep.
yeah. Okay. How about the other three?
Number up to num. As you, this program displays 1, 1, 2, 1, 2, 3 up to the numbers.
Okay, number triangle.
Yeah, number triangle, right.
Can you execute this once?
Okay.
What happens if you enter 1? Okay, what happens when you enter 0?
Nothing came up.
Okay. Okay, how about the other two?
This is prime number.
While dot clause and divisor equals to. What is the num of fact?
Number of factorials.
Okay.
Yeah, this is the divisor which I'm dividing with, and number of factorials is the number of factorials for that number.
Okay.
So here I'm checking positive integer greater than 1 and number of factorial greater than, if it is greater than 2, then it gives it's not a prime number. Otherwise,
Okay.
it's a prime number.
Number of factorials would be 0. Okay, can you run the program? Give to. Okay. Okay. Looks okay to me. However, you don't really have to verify until num minus 1. According to your logic, you are verifying until num minus 1, right?
Right, correct.
Okay. So what you what you can actually do is, uh, there are two things. One is you don't have to verify. Uh, Say for example, there is 25. According to you, you will verify until 24. Like you verify for each number until 24.
Right, right.
Okay. So, but check. See, 5 into 5 is what? 25, right?
Right,
Okay. So after that, 6 into 6 leads to 36. So you don't
right.
really have to verify for any numbers that are beyond 5 for verifying for 25.
Correct, correct.
Okay, so that way, if you say divisor into divisor is less than or equal to num, if you less than num, then you can actually uh, um, stop that loop. Like so, in that while loop condition, you can, instead of saying divisor is less than num, you can say divisor into divisor is less than num.
Right.
Okay. That is one improvement that you can make. So that actually gives a significant improvement. Let's say you are verifying for a number 625, you will be doing 624 comparisons, loop iterations, whereas you only need to do 25 iterations to verify.
Correct, correct.
Okay. And another improvement is, see, if there is a divisor, okay, you don't really have to verify anymore, do you? Say number of factorial has become 1. Assume that. Then do you really have to divide it by the other numbers?
No, that is also not required. Correct.
Not required.
So,
So what we can do is we can use a break in that if statement after line number 17.
right.
Okay, so that way that actually comes out of the loop. So the reason why I'm actually suggesting the improvements is because most of the time when you are actually being part of a development team, uh, you will be having discussions about how to optimize the code and so what you have to understand is there are many ways of writing code, and some improvements will actually some changes will actually improve the execution time. Okay,
Right.
so these are all like algorithm execution times and all will be not too much of calculations will be done, but still a slightly better algorithm will be appreciated better than an algorithm that is taking longer time. So think always. I see your solutions are good. Just take one step ahead and see if you can find even a better solution to reduce the number of calculations that it's taking, the iterations it is executing.
Right.
Okay.
Right.
Uh,
We'll do that.
what is the other program? I think fifth one is also there, right?
Yeah, this is prime numbers between two integers, two numbers. I mean.
Okay. While number 3 is less than number 1, number 3 is less than or equal to number 2, number 2 plus plus. Okay. While divisor is less than number 3, if number of factorials equals to 0, then you are printing that number. Okay. Uh, Looks good to me. Now let's go to the next topic. If you guys have any questions on whatever we covered so far,
One question I have,
yeah,
Buddha. So you said that we can break the loop in between, right? So
yes,
this is applicable to for loop also, right?
yeah, every loop.
Okay. So if there are nested loops, it will go to the immediate uh, loop which is ahead of it. Is that the way?
Yeah, if you say if there is a break in line number 21, then whenever it encounters that break, it comes to line number 25.
Okay,
Okay, that means it will still be in the for loop, but it will be out of the while loop.
I
So
got it. Okay.
it comes out one level only.
And another question is when I'm running the program, if I want to stop in the middle, I'm pressing this
Yeah,
terminate button.
yeah.
Uh, but actually, in the real life,
Uh-huh.
how it happens if let's suppose we are running a huge application, it's stuck somewhere or something happened, it's not coming out of that program. Uh, is there some way that we can cancel it in the middle, or is it too early to discuss that point?
Not too early or anything, but it all depends on how you are executing that program. Okay,
Okay,
say you are executing that program using Java Java and giving the class name.
uh-huh.
So what happens is if it is stuck over there, you will be pressing Control C
Okay,
if you are executing the program from command line. Or if you are executing some UI program, then generally you also don't have any option to do that. If MS Word gets stuck, right, you go to Task Manager and end it forcefully.
right, right.
So that's the only way that you can do for this also.
Okay, got it.
But in Task Manager, it will be showing as Java. So it won't actually show prime b to int dot class or anything. Okay, so there in the task manager you may have multiple Java programs running in your computer. So you have to be careful about which Java you are closing.
Okay,
So any other questions, Srinivas?
that's it, Buddha.
Okay, fine then. So let's come to a little more. Can you see my screen?
Yeah.
Okay. Now let's get into a little more object-oriented way of solving the problems and thinking. So now in this we will be learning about methods. What are methods, or in other words, they can also be called as functions. And we'll learn about we will get a small introduction to classes, what classes are, how can we make use of them, etc. So let's come. Let's imagine there is a problem called prime borders. Okay. So as per this problem, you have to read two numbers. Okay. And if test if both of them are primes or not. Okay. If both are prime, you have to print all prime numbers between number one and number two, including number one and number two. Okay. If only the first number is prime, you have to print all even numbers between those two numbers. If the second number is prime, you have to print all odd numbers between these two. If none of the number is prime, you have to print all numbers between them. So what I've written over here is pseudocode. Okay, pseudocode is like an English descriptive solution to a problem. Okay, how am I going to solve this problem? Forget about which programming language you are using, what is the syntax. Okay, sometimes if you go to some programming interviews, you may be asked to read some write some pseudocode. Okay, pseudocode, when they ask you to write pseudocode, this is how you write in simple plain English about how your program solves it. Okay, or even if you are asked to do that manually without using computer to solve that problem, how will you do? You will do this only, right? You will first ask, okay, what are the two numbers? You take the two numbers and you test if that first number is prime or not, and then you test if the second number is prime or not. Based on that condition, you will execute the subsequent things. So if both are prime, you print number one, because you have to print number one and number two also, and then test if it is a prime number, and go to the next number and test if that is a prime number, and so on and so on and so forth. You go until you reach number two. That is one condition. Okay, and if in another condition, if else if first is prime, you start at number one plus one, because you have to print all even numbers. So because first is prime, that is already an odd number, so you start at a number that is after that prime number, because after odd number immediately even number comes. So and from there, print number at that position and increment the counter by 2 and repeat steps 2 and 3. Okay, so what happens? You say 5 and 17 is given. Okay, 18 is given. So because 5 is a prime number and also an odd number, you don't have to print it, because only the first number is prime. So what you do? You do 5 plus 1, which leads to 6. So you start at 6, and then you don't visit 7, or even you don't even care about testing whether the next number is even or odd. What you do? You printed 6, increment by 2, so you get an even number. Then 8, 10. That way you don't even have to do any verifications at all. And else if second is prime number, what you do? If number one is odd, set the counter to it or move the counter to number one. So you are going to do that before the loop starts, and then counter whatever number is there at that counter, you print it and then increment by 2, so it keeps on getting odd numbers. So in else part, what you do? You start at number one and print number two. Print at that number at that counter, and go until you reach the number two. So you repeat the steps two and three. So assume that we have to solve this problem. How would you solve it? You have already seen how to check a number as a prime. Okay, but imagine see this problem more closely. We are actually testing that condition in three different places. Okay, one, to test whether the number one is prime or not. Two, testing whether the number two is prime or not. And third one, if both are prime, so in that loop we are actually testing if it is prime or not again, right? So we are actually repeating some kind of code, right? So though the numbers are changing, the same code is being repeated to verify if a number is prime or not. Okay, so now let's see how we are going to solve this problem. So, Okay, let's write the program. Let's not worry about it. First, we have to read the two numbers. Assume that we have read the two numbers, and I am directly placing that numbers in the number 1 and number 2. Number 1 equals to say 5, number 2 equals to say 18. Okay, now what do we do? First, we have to test if the number 1 is prime or not. So for int I equals to where shall we begin? At 2, I is less than or equals to I into I is less than or equals to n I plus plus. And then if number 1 can be divided by I, so what we will do is we will store values prime start equals to true. Then if percentage I equals to 0, then prime start equals to false. That means the starting number is not a prime number. So, and then we are going to break. And now what we have to do, we have to execute the same set of code for the n number also. Now what happens is if this particular code will be returning, sorry, not returning, this particular code will be testing whether the prime second n number is also prime. So now how do we do? If prime start ampersand ampersand prime and if both are true, then what we have to do, for int I equals to num1, I is less than or equals to num2 I plus plus, and then for int j equals to 2, j into j is less than I j plus plus, if I divided by j is reminds is 0, then is prime equals to false and break. And after this loop, if that is prime is still true, that means no other number is dividing it. So if is prime, print I. Okay, so now else if prime start, so the first number is the prime number. So when the first number is prime number, what has to happen? it has to print all even numbers between these two numbers, right? So now for int I equals to number 1 plus 1 and I less than or equals to number 2 and I plus equals to 2. Now sys out I, else if prime end, we have to print all odd numbers, right? So if num1 percentage 2 is double equals to 0, let's say int I equals int I equals to num1 plus 1, else I equals to num1 for in sorry for because we are already declared I, we don't have to initialize it. So what we are going to do, I is less than or equals to num2 I plus equals to 2 I. So what this prints? This prints the even numbers between those two. So now else, like if nothing else matches, we will simply start at number 1, go ahead until number 2 I plus plus I. So this problem actually solves the whatever problem I said, the prime borders problem. Okay. So the pseudocode, whatever I've written, is what I'm doing here. When I said test first if first for number is prime or not, I'm testing that using this code, and I'm testing whether number 2 is prime using this code, and testing whether this with using this piece of code if this I is prime or not. So now, don't you see this problem is kind of repetitive. The solution is actually repetitive. So now here what happened? The first number is prime number, so I'm printing all the even numbers between those two. Okay. So if I had given say 19 here, both are prime, so only the prime number should be printed. So now see, if you see, the 9 is not actually a prime number, but still it uh, gave me the printed saying that it's a prime number, right? That means there is a bug in our code. Uh, so how can we debug that code? I'll show you how we can debug that code. But the first let me actually let me actually finish the topic that I'm trying to tell, methods. So assume that this code is working correctly. Okay, so forget that this may not be working because we must have written some logical error here. So that we'll come to that. So before that, what you have to understand is these three pieces of code are doing the same job, finding if a number is prime or not. So what we can actually do is we don't really have to write this code so many number of times. See, tomorrow if there is a better algorithm for testing if a number is prime or not, you really don't have to change it in all three places. If you write like this, you will have to. Okay. So the alternative is to actually write something like this: public static boolean. So let us write a method that actually tests if a number is prime or not and returns true or false based on the condition check it does. Okay, if the number is prime number, it returns true, otherwise it returns false. Okay, assume that that is the beginning. So now let's write a method called is prime, and it has to take a number, and then here it has to have a logic. Okay. Now, what I've done is I've created a method. Okay, methods are nothing but a reusable piece of code. I'll come to syntax of this once again, but let's first try to see how we can use it. So what we can do is all this code can be simply, and now also remember the number of lines this code took. It took around 71 lines of code. Now let us do this. Is prime of number 1, and then is prime of number 2, and then even here is prime of I. In fact, because this is a boolean which is directly going here, we can in fact put that if condition here itself. Now observe a couple of things. One, the number of lines got reduced to 45 for this method. Okay, and also the code is more clear. When I had a loop like this, it's really not clear as to what is happening over here. You know this is happening prime because I have used that clear cut names, okay, for variables and all. If I had not given the clear names for this method and all, you would not understand what is this unless you spend some time. However, check this, read this line. This is much more clear. Like it is saying that okay, prime and boolean loci is prime and a method. We are doing some test is prime, so it is more clear as to in terms of readability as to what is actually happening when we are actually calling this particular line than this. Of course this is simple because you already know this is logic for prime number. Otherwise if I have given you some logic you will not understand. So methods actually help us give a name to a certain reusable piece of code, and we can simply uh, execute that particular code by calling that whenever we need. So if you see, you are actually creating these methods from the day one of your program. Okay, now if you clearly see, this is actually main method. Okay, what you are creating is a main method, and here you have created another method called isPrime. Here we are calling the isPrime method inside the main method. So the main method is the calling function. Main method, so isPrime is the called function. Okay, so what you can understand over here is we can give certain name to a specific piece of code, and we can call that code whenever we want, and we can also pass some data to it. And what this return is doing is this is doing some calculation, and this is passing some result back, and this is passing a result of type boolean. So this is how, when we write the methods, the code will be reusable and clear and also short. And the biggest advantage is tomorrow your logic of finding out how a number is prime has changed. Okay, so what you would do, you really don't have to change in any other place. Okay, all you have to do is come to the is prime method, give that new logic which works better, bam, you have it. So you can actually get what you want. Okay, so now this is not printing 9. Okay, this is only printing 5 to 19. The reason being, the logic whatever I've written in this here, condition here, I must have written some error in that. But what happened over here, when I have moved used the same logic in all three places, I have copied from a place where I didn't do any mistake, so that mistake got rectified. So this is the advantage. If you write the same logic multiple times, you may write incorrectly in one place and correctly in another places, which will result in very confusing piece of execution bug. Okay, so you will not be able to understand what is going on and all. So now because there is only one place, assume that I have forgotten to actually put divided by 3, And now when I execute the program, now what happens? It prints so many numbers. Okay. So because this mistake is only one in one place, what happens is I will have to fix it in this one single place, and that's it. Everyone everywhere else the issue gets fixed. Okay. So now let's continue with the problem. So now what is a Java method? We have seen a demonstration before. Uh, Now let's learn the theoretical concept. Okay, a Java method is nothing but a collection of statements. Okay, that are put together to form a specific operation or to perform a specific operation. It can be mathematical, or it can be uh, some other thing that you actually, in fact, you are using many methods so far. When you said scanner.nextInt, it is actually executing some code that is written in that nextInt method of scanner class. Okay, I'll come to that again. The typical and even the system.out.println is also a method you are calling to actually print some message to the screen. Okay, and let's come to the syntax of it. Okay, syntax will be like the whatever is in yellow color over here, access modifier static, that's actually optional. You don't have to give that. And then okay, now I can come back to the syntax. There will be an access modifier, and there will be a keyword called static. Of course, static is not mandatory, so sometimes you give it, sometimes you don't. When you give it, when you don't, I'll tell that later. And return type is an indication as to what is the kind of data that's coming back, and method name is the name of the method that you are like what is the name you are using for that method. And parameters list, what is the data that you are passing to that method for the for performing or doing some calculation. Okay, and then the method body and the method name including along with the parameter list is called as method signature. Okay, so now let's see. Let's look at it more closely. Okay, whatever code we have written, so now this whatever you see that red bordered section is called as method definition. Okay, method definition is the place where we actually write the code for the method. You may be wondering like when we will not write the code for a method. We will see that later. Yes, there will be some cases where we won't be writing any code for the method. So for now, imagine remember that this is the method definition. Okay, and now if you understand, if you look at this is prime logic, the logic is even more improvised. First, I am checking if that number is divisible by 2 or not. If it is, I am simply returning the false back. If it is not divisible, then I am starting at 3 and not adding one by one number. Instead, I am doing I plus equals to 2 instead of I plus plus. Because it is not divided by 2, so it will not be divided by 4, it will not be divided by 6, etc. So I don't really have to test for odd numbers. Okay, I can only test for even. This way, in fact, when I said the 625 needs only 24 calculations or 24 iterations, now because I'm only testing odd numbers, I'm only doing 12 iterations. Okay, so to test whether a number is prime or not, I really don't have to do so many iterations. In fact, there can be even better algorithms. Okay, you don't have to think this is the best algorithm you can find. There are better algorithms. Okay, so now let's come back to that method definition. Method definition is the place where you are actually writing the code for the function. And now this is the method definition for the main method. Okay, so as I said, you have been writing methods since the day you began learning Java, and this is method call. Okay, so in the main method is calling the isPrime method, and it is also passing a number, a variable named num. Okay, and so in this case, main method is the calling method, isPrime is the called method. And now the main method has a certain parameter list, string, args. We have not been using this so far, okay? But why we are writing over there is because the Java expects our method signature to have the name main and also the parameters list, string, args, an array. We will learn a little more about the string args a little later. and our isPrime method is taking one parameter, okay, which is num. Remember, see that then variable name is num in the main method, and here it is n in the isPrime method. That is because there is no relationship between num and n. Okay, so each are not related to each other in any way. We are simply copying the value in num to n, and now this is return type. So we are telling that isPrime method is going to return boolean data type, okay, either true or false. And then main method is returning something called as void. Okay, we generally use void when that method doesn't return any data. Maybe it is doing some operation, and it doesn't have to return anything. So we have to mention void in that place. And here we have used a keyword called as return, and then we are returning a variable called as res, where we are storing the result of whether a number is prime or not. So whenever it encounters a statement return, it simply returns that value to the calling function. So now the value will be going into the result in line number 5 if you see the code. Okay. Now, how are we writing a method? Sorry, calling a method. Assume that there is a method is prime, and it is taking two arguments. First is integer and then string. We cannot write code. We cannot call that method with only one parameter. We cannot call code with the parameters that are in different order. Like, because it is accepting integer and then string, we have to give an integer and then string only. So giving string and integer is also wrong, and even giving both integers is also wrong. So what is right is giving in the order that it expects. Like, the number is 5. First it is expecting an integer, so first parameter is 5, and the second parameter is a string. Okay, so the return type is, as I said earlier, it's just an indication of what is happening. And then the parameter list, a method can have any number of parameters until 255. After that, it returns some invalid parameter length or some other error. So you don't have to. Anyways, the guideline is not to go for anything more than 4 to 5 parameters. If it is going, that readability of the program will be less and less. Okay, so a function can be doing many things. Okay, a function that can take two parameters and return which of them is minimum. So here we are returning an integer. A function can take an array as an input and return average of them. So it is taking an array where there can be hundreds of elements and adding all of them and finding out the average and returning that value. There can be another function that takes array as input and simply sorts that array and doesn't return anything. Okay, maybe it is simply printing on the screen but not returning that data back. So it can be any type. So let's see how an execution flow goes. Call stack is the place, you can think call stack as memory bucket. Okay, so whenever a specific method is getting executed, that method comes into the call stack. All the variables will be stored in that call stack. Okay, now let's execute this program and see what happens. When we execute the program, in the call stack, that means in the memory, a new area will be registered for the main method and the variables in it. And because string of args is also a variable, it creates that variable. And then once it executes line number 2, it creates a new variable called as scanner, and then it creates num because it is reading that value from scanner and putting that value in num. And then we are closing the scanner, so scanner is gone. And then when it encounters line number 5, here we are calling the isPrime, right? So what happens is the execution of main method gets halted in line number 5, and line number 10 execution starts. So in the call stack, the stack will get the isPrime as the latest location, like highest location. And then because there is a parameter called n whose value is 5, a new variable is registered. And then boolean creates another variable, and all of these are okay. When the for loop is beginning, another variable called I is generated, and it continues, goes on and on and on until it comes out of the loop. Okay, here if you see, I have not broken out of the method. Doesn't matter, it's just a small silly mistake I should have. So now integer I is defined because we are starting the for loop, and the loop gets executed, and in the end the return res value will be returned, right? So what happens is that value comes into the result. So that is how the execution takes place, and then the execution in the main method proceeds as usual. So that's how the typical execution goes on in the method. So just a moment. Now, as I said earlier, main method accepts an argument, a string array. Okay, this actually is command line arguments. Now, imagine there is a program that is reading our name and then printing hello and giving that name like this. See, if you see this this execution, it shows that you are executing the Java program by using Java command, and then it's waiting for that input and printing hello Buddha. Okay, now imagine we want to pass that Buddha while executing the program itself like this. Java command line args demo Buddha, and then it should be able to access that because there is only one value it is waiting for. We can very well make sure that the Java while executing the program itself that input will be accepted. For that, this Buddha is called as a command line argument here. Okay, and the command line argument demo is the class. Java is the executable that is running the class and passing that command line argument to that class. So the main method args will be getting that particular variable whatever we passed, and in the beginning location of an array, that whatever element data we passed after the class name will be stored. So string str equals to args of 0 will actually return the value Buddha, and we are printing that value. So that's how we can actually use command line arguments. In Eclipse also we can use command line arguments. We'll see about that. So now how I'm executing this program, I'm giving this number 1 and number 2, right? There are alternative ways. Like say for example, I want to make sure that I can pass these values from the command line arguments. What I can actually do is here, instead of clicking this run button, when we click the small arrow or small downward arrow beside that run button, we get this menu and go to the run configurations and select the prime borders one because that is a configuration that is executing. And in the arguments, we can give 5 and 19, 5 comma 19. So what happened over here, will be passing 5 and 19 to the program, and we are actually executing, but we are passing it, but we are not using them, right? We are not actually using args so far. So to use them, what we can actually do is we cannot simply say args of 0. Why? Can anyone guess? Srinivas or Kishore?
One is string, but the num1 is integer.
Absolutely. So we have to convert. So how do we do that? We have a class called as integer, which has a method called as parseInt, which takes a string input, string, and converts it into an integer. Okay, and the same can be written for the subsequent number also. Okay, so now these two numbers will be converted. Now I'm not giving 5 and 19 in this program. Now when I execute this, I still get 5, 6, 8, 12, etc. Everything. Okay. Why I'm still getting the issue? Because I'm starting at 3 instead of 2. Now program should be executed fine. So even if we execute that program, now prime borders one dot class is the class that gets generated by Eclipse when we are running this program. It cannot run it like that. It has to first compile. So it will compile and place those folders some class file somewhere. So I'm going there only. I went there and I typed Java prime borders one, and then if I execute, if I give say for example 3 and 8, it says it could not find prime borders one class file. Is it prime borders or prime borders one? It is correct only. Okay, that is because something called as packages. I'll tell you in a moment. Java arg dot training dot rep dot methods dot prime borders one, and we are giving 3 and 8. Now it printed all the even numbers. Now if I execute the same program by using 5 and 19, it prints all the prime numbers between them. So when we are executing the program itself, we are going to pass this data. Okay, so now if we are executing it from Eclipse, if we want to pass some data, what we have to do, we have to go to run configurations and go to this arguments and pass these values. So now we are passing 5 and 19, right? If we pass 5 and 18 and say apply and run, Eclipse will be passing those values and it is executing that program. Okay, so it printed all the even numbers. So that's what we are expecting. So however, when in the command line, you have to pass that every time because the Eclipse is remembering those two and passing them to simplify our work for debugging some of the things. But this is how you execute, and if you are executing it from command line, that is why these are called as command line arguments. The 5 and 19, 3 and 8. So these are all command line arguments. So now, I would actually like to introduce a concept called as binary search. I'm just thinking. Okay, I think the time will be sufficient, so let's go over it. Imagine you have an array called array like this. Okay, so you have to find an element. So how do you find it? You first begin with the first element and then check if that element is equal to the element that you want or not, and then go move to the next element, and you do that until you reach the value that you're looking for. So let's assume we are looking for 2. We cannot simply go and pick up. Okay, we are able to see 2 here, but still how we are actually doing it in our brain, we are starting from left to right, reading one number and going ahead until we find the number that we want, and when it finds, we are telling yeah match found, and we are returning that value, or we are telling we are simply returning true or false. But the number of operations that we have done over here are 9. Assume that one comparing one number is one operation. We did 9 operations. Okay, so that's okay, it's well and good. What if there are million elements in your array? So you have to compare all 1 million elements. Okay, but if the array is in a some kind of unsorted order, like random order, you cannot do anything else except for verifying all the elements. So that's why generally what people do is they generally sort the data, because when we sort, we actually have another method called as binary search that actually simplifies the search. Assume that we are trying to search for 2, okay, in a sorted array. Now, instead of starting from the beginning and going until linearly until the end, what happens is if we go until, say, for example, we have to find 313. If we do linear search from the beginning, what happens? We will be still ending up doing 9 or 10 operations. Okay, but binary search works in different fashion. What it does is it marks the beginning variable and ending variable as start and end, and then it finds the average of starting and end in terms of indexes, and then whatever value that is there in the middle of the array, it compares the number that you have to find with that. Say now 2 will be compared with 63, it is not equal, so we did not find the match. Because the array is sorted in sorted order, every number that is on right side of 63 will be greater than 63. So now what we will check is whether that number we are trying to find is greater than or 63 or less than 63. If it is less than 63, we don't have to search in the elements that are on the right side of 63, because if the number 2 is less than 63, that will never be on the right side of 63 because it is sorted. So now what we will do is we will move the end marker to this one element beside the 45, 63, and now the array that we have to search has become half, almost half at least. And now we will find again the midpoint and compare with that, and because it is still less, we will compare with that, and we find midpoint, and we do that until we the start and end becomes 1. Okay, so then we will be able to find the actual value that we want to find, and the total number of operations are 4 only. So this way we can actually simplify or write an optimized code to find the elements in an array if that element that we are searching for, the array we are searching in is already sorted. Okay, so this is called as binary search. Why it is called binary search? Every time we are breaking that array into two sections, two parts. So 2 is nothing but binary. So this searching algorithm is called as binary search. Okay. So there is another concept called as recursion, but I don't want you to actually learn about recursion at this point of time. Recursion. Okay, let me cover these also. I'll finish complete methods. So recursion uh, is another way of solving. See, we have just saw that a problem of finding elements in an array will be in two different ways. Okay. However, uh, there will be some problems which are not that easy to think in iterative mode. Okay. So what you have, the problems wherein a bigger problem is dependent on other smaller subset of the same problem. If we have that kind of problems, writing things in loops will become more complicated. So recursion allows us to do that. Recursion is nothing but calling a method within itself. Like say for example, we are calling is prime from main, right? What if you call is prime from is prime method itself? That is called as recursion. Some problems can only be solved by using recursion approaches. Okay. So how do you think? So assume that you are actually trying to find factorial of a number. So factorial means if say we want to find out factorial of 5, we have to multiply 5 into 4 into 3 into 2 into 1. Then you will be getting the factorial of 5. Okay, so now iteratively how will you solve it? You will set int I equals to 1 and say I is less than or equals to n and I plus plus, and then factorial variable you will initially set it to 1, and then you will be keep on multiplying these indexes. Like first you will multiply it 1, and then you multiply it with 2, and then you multiply it with 3. So that way you think iteratively, okay, what I can repeat in terms of trying to when I have to find the algorithm sorry value of factorial. Okay, so this is one way of thinking. There is another way also, that is recursion. That is, instead of thinking the solution for 6 factorial is 6 into 5 into 4 into 3 into 2 into 1, you think the solution for 6 factorial is 6 into 5 factorial. So when you do that, what happened is the problem of finding factorial has become a problem of multiplying 6 with a smaller problem of finding factorial for another number, which is 5 factorial. Now, when you have to solve the problem of 5 factorial, again that becomes 5 into 4 factorial. So what you see is, instead of thinking iteratively, we are actually thinking by making the problem into smaller sub problems. Okay, and what we are identifying, we will go ahead until we reach 1. Okay, after that we don't have any more multiplications or factorials to be found. Zero factorial is not defined, so we don't go there at all. So now what we got over here is, we will be able to find the factorial by defining it either by 6 equal to 5 into 4 into 3, 6 into 5 into 4 into 3 into 2 into 1, or we can also define it like 6 into 5 factorial. So when you divide in this, when you make this problem into, categorize the problem into second way of thinking, that is called as recursive solution. So for the recursive solution, you have to have a base case where you are going to stop. Where we are going to stop in this case, when we reach 1. We don't have, when we have to find 1 factorial, that's where we stop. And the recursive case is identifying factorial of smaller numbers. So that's how we try to solve this problem recursively. Okay, so we can write the program, but I want you to write the program of finding a factorial iteratively and recursively. Okay, and in fact, I'm actually showing a code of how binary search works iteratively. Okay, we are starting at start equals to 0 and ending at and end is start is at 0, end is at array.len, and mid is at start plus end by 2, and then we are comparing whether the current value that we have to find, that x is equals to array of mid. If it is equals to, we are returning that, saying that element is found. Otherwise we are checking if that element is less than array of mid or not, and then we are returning if we are actually setting the end to mid minus 1, or setting the start to mid plus 1. That is how we are solving that binary search problem iteratively. If you have to solve that binary search problem recursively, how you will do, instead of setting this end to mid minus 1, you actually call the recursive binary search method uh, from recursive binary search method by passing start and mid minus 1. See, initially when the main method is passing 0 and end, that means it is telling the entire array, and then the recursive binary search is calling that same method itself, but this time it is calling by passing the start and end. Instead of end, it is passing mid minus 1. So that means it is reducing the amount of elements that it has to pass. So the next iteration, we will be considering only those two, and we will be verifying. So this way we can actually solve this problem recursively also. Okay, there are some famous problems of recursion. Say, for example, there are three poles where on one pole there are disks on one top of another, and now you have to move all these disks to the third peg. Okay, but the only rule you have to follow is, you can use the second peg, but you cannot place a larger disk on a smaller disk. To solve this problem, I, solving it iteratively is very problematic. Okay, so your program has to print the steps you have to take to actually move. So this GIF is actually doing that. Okay, so in this animation, if you have to write in your program like the output of the steps that you have to take, if you have to solve it iteratively, it is going to be a very big problem. So you generally think recursively. So I don't want to actually solve this problem now in the session. If you are interested, go ahead and try to solve this problem yourself by using recursive. You can find the logic outside if you cannot understand the logic, but still, if you do, you will get a fair understanding of how recursion works. Okay, and another problem is file system traversal. So now imagine you have to read every file that you have in computer and find out how much size is occupied by all the files. Okay, so in that case, what you do, You have a directory, you go into the directory and you read all the files, but that's not where it stops, right? That directory may contain another directory, and you don't know how many levels you have. So imagine reading a directory is a method. So now inside a method, when you're reading different entries, when a directory is found, call that same method within the same method. Like read directory inside another read directory method. So what happens? That inner directory method will be read by using the same logic. Okay. How when will you? What is the base case when you don't have any directories in a specific directory? That is the base case for a specific directory. So when you have read all the directories, then you will be coming out saying that okay, I have this many number of files that are there in all the folders that we have selected. So that kind of problems can only be solved by recursively, because you don't know what is n, right? In see when you are sorting array, you have hard coded n to 4, but when it comes to your computer, you don't have any limit as to how many directories you can have. You can have any number. Okay? So in those cases, we actually use recursion to solve that problem. Okay, so it's up to you. If you are interested, try to solve the towers of Hanoi problem. Otherwise, try to simply try these binary search programs yourself once and try to execute them and see how the output comes. Okay, so Java allows us to use a concept called as polymorphism. Okay, polymorphism is not of Java. It's a object oriented program. I mean, it's an important pillar of object oriented programming thinking. So it's like writing the multiple method with same name in the same class, but signature can be different in the same. When the name is same, signatures can only be differed by changing the parameter list. Okay, so we can actually write that is prime method that takes one parameter, and is prime method that takes two parameters in whatever way we want, and each methods can coexist without any issues. I'll show a small demo later. uh, Along with this, we have also left out some topics that are actually public. What is public static, why we are writing those two, I didn't speak about them. So I'll tell you about those things when we actually come to a concept called as classes, which is actually the next one. But I'll take that in the next session, which happens on Friday morning. Okay. Um meanwhile, I want you to write the try to solve this problem. Say you have got an input string like hello. You have to scramble it, like jumble the letters that are there inside that word and return me a scrambled word. Okay, and each time I do, it has to return a different set of scrambled word. Like when I said hello or scramble hello once, it has to return LLEOH. If I scramble again, it may have to return HLLOEH OIE. That way, it has to return me a different set of scrambled word. So I want you to write a method that takes string as an input and returns string, and the string return that is returned is a scrambled form of the given input word. Okay. So for this, you can use a utility called as random to generate a random number if you want to generate random numbers, or if you want to solve it in any other way, you are feel free to solve it. Okay, so this exercise I want you to do, along with if you want to try binary search recursion problem, try that also. Otherwise that is fine. Just get yourself familiarized with these topics, and we will see the next topic classes in the subsequent session. Okay, so have you guys got any question on this problem or whatever we have covered so far?
Yeah, Buddha, like in you have shown passing arguments through command line and through Eclipse. Do we use really in product?
uh, I'm sorry, I muted you accidentally while unmuting myself. While we use them really in production is what you asked, right?
Yeah, like in command through command prompt line you pass it the values, right?
Yes.
And through Eclipse we have given the values. In production environment, how it is useful? I mean, what is the production scenario?
See, production scenario can be. There may be some other. See, most of the times we won't be using these command line programs at all. That
Okay.
is for sure, right? Okay. Assume you have your. Let's speak in terms of the mainframe itself. Let's say there is a mainframe job that is triggering a specific Java program.
Mm-hmm.
Okay, by executing Java command, and
Mm-hmm.
that can pass some arguments to it. Okay,
Mm-hmm.
maybe let's see, a batch job may take a file name as an input that will be processing all the records in that file and doing some operations on that file. Okay, so but as I said, in most of the production environments, we won't be really writing command line related programs. Again, depending upon the requirement. If you are developing a web application, you will never be doing this. If you are developing some GUI application, even in that case, you may not be able to do that. But in some cases, we will be. Uh, let's say you are running Notepad, okay, in your
Mm-hmm.
Windows. Okay, that's a production environment, right? For Microsoft, that is the production environment. You using Windows is the production environment for Microsoft.
Okay.
So you're running Notepad. Okay, you may not, you may think that okay, why Notepad is not accepting anything, right? But uh, try typing in the command prompt notepad abc.txt. It actually opens up a file called abc.txt. And even Internet Explorer, if you say iexplore.exe and give a website address, it will be opening that website address. Okay, so though we may not use it because this is not that comfortable than double clicking the mouse icon or clicking a specific icon, that is
Mm-hmm.
still a possibility. Okay, for others to expect to use that fashion. So 99% of the time, no, we don't even be writing a program with main methods. Okay, but still there are cases where you may have to do that. So we are just learning them. So keep in your subconscious mind so that it is possible. So if you need it, you will be using it. That's it.
Okay, got you, got you. And also you mentioned, I mean, using recursive method
Mhm.
to find the number of directories in the subfolder.
Yes.
I mean, how, how can I write that one code?
See, you will understand that a bit more when I actually cover a concept called as files, wherein we actually read a concept, see how we can read files on a file system, etc. Is
Okay.
your specific doubt about how do we read about files, etc., or is it about recursion?
Uh, no, no. If I want to try right now, uh,
You
do
cannot
I
try
have
right
this?
now because you don't know some concepts that are related to
Yeah,
files.
yeah. I was about to ask that one. Do I have the sufficient knowledge to try it, or am I missing
No,
something?
that problem you don't have enough knowledge to that specific problem.
Okay,
Okay.
fine.
So we have to cover a topic called files. Then you will understand how to read files, directories in the file system using Java code. Then you will be getting that.
And also on this exercise, hello,
Yeah.
uh, you said each time it should return a different scrambled word.
Yes.
Okay.
Yes.
But if you also said some utility, random utility, so
Yes.
it can
It can help
give.
you. It can help you give a random number. Let me show how do we use that random number because it doesn't matter what we use. So let's come to this prime number problem itself. Instead of taking two numbers like this, let's say uh, there is a we can use this random utility like this: random r equals to new random. Okay, now if you say r dot next int and gives a number, say for example 100, it will be returning me a number that is between 0 and 100. Some random, if you call this one time, it will be returning one number. If you call this another time, it will be returning some other number.
Okay.
Okay, so now in this first input, let's say r dot next int, let's give 10. So it may return any random number that is between uh, 0 and 10. So if we run this program, Once I got output 9 to 18, that means both are not prime numbers, so I got this. Now if I run this program again, now if you see, I got a different output.
Okay.
Okay, so this r dot next int and given number, it will be returning some number. So I gave you a small hint. I'm not telling you where you have to use that, but if you use that, you will be able to achieve that true randomness. Like for one time, when a user is executing that, he will be getting one output, and another time he will be getting another output. So it's up to you to figure out how you can make sure that you can use this program to actually achieve what you want. Okay, any more questions? Okay, I'm assuming there are no more questions. So I'll be sharing this video and PDF as well. So just go through the PDF. Don't worry, the topic cover classes I haven't covered yet. Like line number from slide number 58, I haven't covered that. I'll cover in the subsequent session. Okay, so till slide number 57, you can go through and try to solve the problem that I have given. Okay, so that's all. Let's meet you on Friday. I've also scheduled an invite for Friday and sent you all invite. I think I have not done that yet. I'll do that and I'll send you all invite for Friday evening, and see you then. And meanwhile, if you get any questions, feel free to ask in that WhatsApp group. Unless that question is too long, or question takes too long to answer, I'll be simply responding there itself. Okay, so if it takes too long time to explain WhatsApp, then I will ask you to wait until the session. Okay, so that's it from my end, guys. See you on Friday.
Okay,
Bye.
Buddha.
I'm sorry. Anyone try to ask some question? Okay. Okay then.
Srinivas, are you there?
I'm sorry.
I'm just asking Srinivas if he is there.
Hello, Srinivas. Can you hear
Okay.
me?
Yeah, I muted myself. Yep.
Okay. 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 Yeah.
Okay,
Okay.
okay.
Yeah. You're also clear, right, on these problems?
Yes.
Okay. Okay then. Chalo, guys. See you on Friday. Bye bye.
Bye.